Hello class and welcome to lesson 7.4 in the geometry unit. I wanted to let you know that thus far we've been dealing with composite shapes, irregular shapes, regular shapes, 2D and 3D shapes, but today we're going to be taking a look at something that in the past has been pretty basic, which is called circles. However, we're going to take a look at different parts of the circles. So you're probably going to learn some new things today with properties of circles. We're going to start off with kind of like some terminology here. So it says, label the diagram with its name. So number 1, that's a line straight across. So you're going to move that. That's called the diameter. Number 2, when you take a cross section that's not through the origin or the center of the circle, we call that a chord. Now this might be something new. Number 3, it's along the outside. It's not the entire outside, which we would call perimeter, or in this case circumference, because it's a circle. Now we're going to take a look at some shading stuff. So if you take a chord and you shade it to the outside arc, that's going to be what we call a segment. Okay? Number 5, if it's blank and there's nothing added to it, we call it a circle. And usually we just label a point in the center. O usually is what the textbook and workbooks use. All right. Number 6, a line that goes straight through and extends beyond the two sides of the circle. We call that a secant. Okay. An important one that we're going to be dealing with the next couple days is called a sector. So a sector is kind of like a piece of the pie, if you think about it, okay? Number 8, we're focusing on the angle itself, not the shaded region, okay, which is called the central angle. So a sector has a central angle, if you want to think about it that way. 9, this is something you're going to learn today, which if you end up taking functions or calculus, you're going to learn about the tangent of something. Now the tangent, ladies and gentlemen, when you put a tangent on, it is always going to be 90 degrees from the radius. Okay? Even though they don't show it, if they say tangent, that's what they're going to mean, okay, ladies and gentlemen? And the last one is called an inscribed angle. So it's an interior angle that is not from the center. So just remember, compare number 8 to number 10. The central angle is the angle formed at the center of the circle, whereas inscribed is not at the center. All right, so there's some terminology. Make sure you know how to draw those or to describe them for your upcoming unit test. Now we're going to take a look at some formulas for circles. Now you should be most familiar with the first two. The first is the area of a circle. The area of a circle is the entire shaded region inside. So all of this is what we're looking at. Okay, is the surface area inside that. Whereas, ladies and gentlemen, we take a look at the circumference of a circle, it's the measurement around the outside. Circumference is a special name for perimeter of a curved side. Well, perimeter deals with the addition of the outsides being added, but we don't really classify a circle as having sides. So that's why we come up with the terminology circumference. And it can be based on the radius or on the diameter. All right, now we're going to take a look at some new ones, and we're going to be doing some calculations with it, okay? So arc length is a new terminology, okay? Arc length is this red arc here. I'll just change it to green so you can see. That's what we're focusing on. How long is that arc with a central angle? So you have to either be given the angle to find the arc or give the arc length to find the angle and with the radius given. Okay? So as long as you have 2 out of the 3 pieces of the puzzle, you can find the third piece. All right? And the lowercase a is a measurement. Okay? So let's take a look at this example. We're going to follow this example through the next 3. So we're going to have a radius of 10 centimeters, so that means r equals 10 centimeters, and a central angle of 52 degrees. So we can find a. So a, if we substitute this in the formula, a equals 52 degrees over 360, and that's really degrees as well, times 2 pi times 10. Okay, I always like to simplify, ladies and gentlemen, because I don't want to round too early and have decimals that make it inaccurate. So I'm going to use my fraction button. So I'm going to go 52 fraction button 360 in my calculator, and that's going to give me 13 over 90. Notice the degrees will cancel out. And then I'm going to go 2 times 10, which is 20 pi. Okay, a little bit more I'm going to do here. I'm going to multiply 13 by 20. So that's going to be, my fault, 260 pi divided by 90. And then once you've got it simplified like that, just plug it in your calculator as is. Okay, all right. So plug it in your calculator and you should end up with approximately 9.1 centimeters. We'll just round to one decimal place for all these, and for the angle we'll get to the nearest angle when it asks. So lowercase a is the arc length. Okay, lowercase a. Now we're going to move on and talk about what's called the area of a sector. Notice that's capital A for area. Okay, and it's the red shaded area we're looking here in this within the sector. Okay, so let's use the same example as above. Okay, so area equals 52 degrees over 360 degrees times pi times the radius, which is 10 squared. Now, ladies and gentlemen, I know in the past if you've had me, I've never said just put in 3.14 for pi, because that is, again, rounding it a little too early. So I wouldn't use that. I would save it to the end and then plug it in. So let's simplify again. Use a fraction button. So 52 fraction button 360 gives you 13 over 90 times 10 squared is 100 pi. Okay. Simplify that, you're going to have 1300 pi over 90. You can simplify that even more to make that 130 pi over 9, just to divide. That's a quick shortcut, guys. Divide each by 10. Okay, and here we go. Plug in your calculator, and you should get approximately 45.4 centimeters squared. Okay. Last one we'll deal with here, ladies and gentlemen, is called the area of the segment. Okay. Now the area of the segment will not be touching the central angle. Okay. All right. You have to have a central angle to create the chord initially. So the segment attaches the chord and the arc. Okay, so the area for that has a different formula. So let's use the exact same example we have above with the radius of 10 and the angle of 52 degrees. Okay, so area equals 1/2 times the radius squared, so that's 10 squared, times pi over 180 degrees times 52 degrees. Minus the sine of 52 degrees. Okay, let's simplify where we can. So we know that we've got 10 squared, which is 100, but you can divide it by 2, so there's going to be 50 on the outside. Times, in this bracket, I could do 52 fraction button 180 for the degrees, and degrees will cancel. So I end up with 13 over 45. And I have pi, so it's 13 pi over 45, subtract sine of 52 degrees. Please be careful here, folks, because this bracket needs to be solved first. So this is where you are going to have some decimals, so leave the 50 out front first. And let's say, I don't know, 4 or 5 decimal places just to keep the accuracy on it. So plug this in your calculator all at once. So I would go 13 pi divided by 45 equals, subtract sine 52 degrees. You should get in your calculator 0.11956. And then you multiply that by 50, so just go times 50. And in your calculator, you should get something like 5.978. And so that's approximately 6.0 centimeters squared. I'm going to fix that up because it looks bad there. So centimeters squared. Just remember, area is a squared unit. Okay? All right. So these formulas, ladies and gentlemen, are in the beginning of your workbook. That's why they've got the Roman numerals. So that's Roman numeral page 9 or Roman numeral 9, the beginning of your book. All right. Let's have you try one, ladies and gentlemen. So let's try one of these on your own. See if you can do this. Okay, so number 1, the area of a circle has a radius of 16 centimeters. So R equals 16 centimeters, and a central angle, which is theta, equals 80 degrees. Determine the area of the sector. Okay, so I would like you to pause the video right now, put it on pause, and do this yourself. Have you paused it yet? Okay, pause back off. Here I am. Let's go over. Hopefully you did this and got the right answer. Hopefully you've tried it yourself. So you should have had area equals 80 degrees over 360 degrees times pi times 16 squared. Okay? Use your fraction button to simplify. You should have 2 over 9 times 16 squared pi is 256 pi. Okay, simplify by multiplying the numerators. You should have 512 pi divided by 9. And ladies and gentlemen, that is, when you plug it in your calculator, that's equal to approximately 178.7 centimeters squared. And because it's more of a word problem, it's set up that way because it's got words in it. You would say, therefore, area of sector is 178.7 centimeters squared. Hopefully you did well at that. If not, go check your calculations and see what you're doing wrong. Otherwise, come see me in class. All right, last example today, folks, and it's a harder one, okay? It says here the circle has a radius of 8 centimeters with a central angle of 40 degrees. Determine the area of the triangle formed by the radii and the chord. Okay, so again, we're looking at that part there, ladies and gentlemen. So we're looking for the area, determine the area of the triangle formed. So although that area is given, ladies and gentlemen, I apologize. The area that, oops. Let's see if I can undo this for a second. Undo. There we go. So the area we're actually looking for, ladies and gentlemen, is the triangle. Okay, so we've got to figure out how do we get that triangle specifically? Well, we have to say, hey, we have to do an introductory statement because it's a two-part question. So area of the triangle equals area of the sector, which is like your whole pizza slice, okay, which would be, if I used a different color, would be this, like your pizza, okay? So that's kind of like your pizza slice. Subtract the area of the segment, which is colored in the reddish color. Okay, so that's something to make note of, okay? So, area of the sector, ladies and gentlemen, if you look back to the formula on the last page, I just write it out. It's pi, sorry, my fault. It's the central angle over 360 degrees times pi r squared. Subtract, I put the area of the segment formula up above because it's a harder one. I'm not going to expect you to memorize it, folks. Just so you know. All right, this is our last question. Now we can plug in our information. So the central angle here, folks, is 40 degrees. So it's going to be 40 degrees over 360 degrees times pi. The radius is 8 squared. Okay, subtract 1/2 of 8 squared times pi over 180 degrees times 40 degrees. Subtract sine of 40 degrees. All right. Use your fraction button to simplify things here, folks. Okay, so 40 degrees fraction button, well, 40 fraction button 360 is going to give you 1/9 times 64 pi here. Okay, subtract, do some work here. So 8 squared is 64. Half of that, because you divide by 2, is 32. Okay, so it's going to be 32 times, use your fraction button here. So 40 fraction button 180 is going to give you 2/9, and then you times it by pi. So 2 pi over 9. And then subtract sine of 40 degrees. Okay. So we can simplify this a bit and make it 64 pi over 9. Subtract 32. And then remember, folks, because of this, we have to simplify things first. Okay. So plug that in your calculator, ladies and gentlemen, and I'm just going to erase that, folks, because you can do that all at once. Because you could have set, well, actually, you could say 64, sorry, my fault. You have to do, there's a set of brackets missing here, folks. You need to do this part first here. So the 32 goes first, like I had. Okay, so plug all that in your calculator. I'm missing this bracket right here. This is the one I was talking about here, this one. Okay, so do this all in your calculator first. So go 2 pi divided by 9 equals, subtract sine 40, and you should get 0.0553. Okay, simplifying through, that's still 64 pi over 9. Subtract, now times that answer by 32, and you'll get 1.7710. Keep some decimals, folks, because you don't want to round too early. Okay, and now plug it all in your calculator, and you're going to get a grand answer of 20.6 centimeters squared. Okay, so therefore, area of triangle is 20.6 centimeters squared. Don't forget your units. All right, ladies and gentlemen, we're going to be spending the next couple days dealing with circles and learn some more symmetry and learn some simple rules about circles. So we're going to be adding on to this. So it's important that you learn this terminology. Here's today's homework, page 146 to 147, numbers 1 to 6, 8, and 13. Have a fabulous day, folks. Namaste.